Hello everyone, I am Kiran Purohit, a PhD scholar at IIT Kharagpur. Today I am going to give a presentation on the topic Application of Subset Selection in Efficient Machine Learning. These are the topics that I will be covering in my presentation. Let us first discuss about my first work on filter pruning, which is accepted at TMLR 2024. CNNs with its millions of parameters demands huge storage and has memory footprint. It also requires billions of floating point operations, making it resource intensive. Filter pruning can alleviate these burdens by reducing the number of filters. We can cut down on storage needs, decrease the memory footprint, and significantly accelerate inference. Given a pre-trained network, the goal of network pruning is to compress the network by removing redundant parameters. Uniform pruning removes the same percentage of filters from each layer of the network. It does not take into account the varying importance of filters across different layers, which can lead to suboptimal performance. On the other hand, non-uniform pruning removes different fraction of filters from each layer. We designed a faster non-uniform pruning method using a hierarchical scheme with two levels, where the first step is to find the most appropriate filters to be pruned from each layer, and the second step is to select the best layer to currently prune from. These two steps are applied iteratively for non-uniform pruning. Our greedy hierarchical methods can be used for effectively pruning large models. ResNext 101 has 193 million parameters and requires around 8 GB GPU memory for loading. We can efficiently deploy the prune model on edge devices with GPU memory less than 2 GB. Coming to the second topic on in-context learning. In-context learning leverages LLM to acquire expertise in a new task, using only a few exemplars without updating the model's parameter. Here, LLM is provided with a prompt that includes question, explanation, and answer triplet. Providing all training examples is impractical due to cost issues. Hence, exemplar selection methods curate a few exemplars that maximizes the overall accuracy. One way is to enumerate all possible combinations and evaluate them on a validation set, but it is impossible to evaluate all combinations. In black box models, we cannot access the parameters of the LLM. Also, the probability scores from LLM cannot be used for scoring exemplar subsets. To overcome these problems, we propose an exemplar subset selection approach by approximating the loss for a given exemplar subset using a scoring function. The parameters of the scoring function are learned using a novel sampling-based bandit algorithm. Results across datasets are shown here. We can clearly see that our method outperforms both static and dynamic exemplar selection approaches. Thank you for your kind attention.